All right, the first thing I want to do is number one, and I'll read it off the screen. The height S of a ball in feet, and that in feet is very important, is thrown with an initial velocity of 80 feet per second from an initial height of 6 feet, is given as a function of time t in seconds by S of t equals a negative 16t squared plus 80t plus 6. Find the time it takes for the ball to reach the ground. What we're going to talk about is first how to set up the equation. They gave us the equation, but it's always important to know how to set the equation up. So the first thing I'm going to recognize is they said the ball had a initial velocity of 80 feet per second. So I'm going to say the initial velocity, or v sub I, is 80 feet per second. If the initial velocity is in feet per second as opposed to meters per second, then we know our coefficient due to gravity is going to be 16 feet per second squared when we're dealing with gravity in feet, right? If it were in meters, then we would do a 4.9 feet per meter squared, right? When you're dealing with meters, the gravity is measured at roughly 10 meters per second squared. I'm sorry, 10 meters per second squared. And when you're dealing with feet, gravity is usually measured as 32 feet per second squared. But since we're dealing with the parabola, which is half of a circle or half of an ellipse, we only want to take half that gravity. And so that's why we go from 32 to the 16 right here. Now here's what we use. And they told us that the initial height of the object thrown is going to be 6. And I use that height initial as h sub I. And so then we know this. This is how it needs to be set up. Y, or the height of your object, is going to be equal to the negative gravity, because our parabola is going to have a maximum. It's going to look like this parabola right here. It's going to have a maximum. A negative gravity, x squared, plus our initial velocity times x, plus our initial height. So if we wanted to write this equation out, we would say our negative gravity, we have already declared that our gravity is going to be 16, so that would be negative 16 x squared. Our initial velocity, which is 80x, and our initial height, which is plus 6. So now we have our formula. Now we need to know that the problem is asking us to find the time that the ball reaches the ground. So if we look at the y-axis, say this graph represents the ball. Where it hits the ground is right here, right? And so if it hits the ground right there, then we know that as a root. And how do we find the root? We use either the quadratic formula, we factor, or we graph. Now we can graph this, but we're going to use the quadratic formula this time. And so what we're going to know is that for this to hit the ground, the y value would be 0. The y is just the height, because if we look here, if I'm going up on the y-axis, that height changes every second the ball travels. The x represents the time, and the y represents the height. Right? And so now, if the y represents the height, we want to know where the ball is where y equals 0, aka where the ball hits the ground, right? Your height is 0 when you're at the ground. And so now I can rewrite this as 0 equals 16x squared plus 80x plus 6. Now I can do one of two things. I noticed that negative 16, 80, and 6 all have a number in common, and I can factor that out or divide both sides of the equation by the number they have in common. Or I can use the quadratic formula to solve for it right now. Either one of those will work. I'm going to factor it out first just because I like to make things easier for myself. The number that they all have in common is 2, so I'm going to divide both sides of this equation by 2. 0 divided by 2 is 0. 16 divided by 2, that's going to be a negative 8x squared. That's going to be 40x, and this is going to be 3. So now I put everything into the quadratic formula. X equals negative b. So x equals here, negative b, negative 40, plus or minus the square root of b squared minus 4 times a times c all over 2a, and a is -8. And so now I can really start moving things around here. 40 squared is going to be 1600. Once I evaluate all this under that sign and then take the square root of whatever number that is, I'm going to have a plus or minus roughly 41.2 or 41 2/10. All that divided by 2 times a -8, which is going to be a -16. And now I would have to take into account a scenario where I have a -40 plus 41.2. -40 plus 41.2 is about 1.2 divided by a -16. So that's my first value of x. Once I determine what that really equals, it's going to be around a -75 thousandths, which cannot be my answer because my ball cannot land. It cannot take a negative amount of time to hit the ground. So that answer is going to be what mathematicians like to call extraneous. It's not going to be the one we want. And so let's take a look at the other root. And so I'm going to have a -40 minus 41 2/10. That's going to be 81 2/10. Divide that, and that's going to be a -81 2/10. Divide that by a -16. In this case, x would equal roughly 5 seconds. This is the one we want. It's positive. You can take a positive amount of time to get somewhere. You cannot take a negative amount of time to get somewhere. So this is not the one we want. So the ball is going to take 5 seconds to get there. I want you to do the rest of the problems on that page. Please contact me if you need any help. Have a great day.